Thanks very much. I am so excited to be able to share more about what we're doing. My name is Charles Manning. I'm the CEO of Kochava. Kochava is a company based out of the United States. And we provide measurement and analytics and attribution technology for digital advertising. So in the context of the introduction, it is about fraud, but it's fraud in the context of digital advertising. We are a company who started 6 years ago. We have 130 employees on our team. We've got offices in our headquarters location, which is in Sandpoint, Idaho, which is a interesting ski resort town in the northern section of Idaho, which is in the Pacific time zone, but still kind of pseudo in the middle of the country. And we have offices as well in Los Angeles, in San Francisco, in Singapore, in South Korea, in Beijing, and in Ireland. We have customers like Machine Zone, who build the games like Game of War, Final Fantasy, Mobile Strike. We have customers like McDonald's. We have customers like NBC, Netflix. One of our customers is, in fact, Coinbase. So what we do is we measure all of the things that are happening with that app or that website, and then we help that advertiser appreciate how they're spending their ad spend and then what that ad spend is resulting in. And so in this space, what that's called is return on ad spend. In addition to providing this measurement technology, because we're at this nexus of all of these different advertisers and all of the places where they're buying ads, we're in this very unique position where our technology is being used to help find new audiences for people who want to acquire that tool or that technology or that product or service that our customer, our advertiser, cares about. And we have effectively a mobile-first DMP, which is an ad tech-like term for a data management platform. It helps you understand the audiences you want to go find. More importantly, for the purpose of this discussion, we also have a fraud monitoring and fraud mitigation technology as part of that. And the function of that is that we're seeing all of these impressions of ads happening in real time all over the world. We're then seeing resulting clicks from end users as they respond to that ad if they have intent. And then we're seeing activities of those audiences in the context of them downloading the apps or going to a website or doing something, performing commerce in some way. And because we're in that nexus, we tend to see very, very high volumes. And as an example, we are dealing in a world of between 1 million to 2.25 million transactions a second at any given time. And so right now there are things happening across 150 some nodes worldwide in our system, which for the sake of this discussion, this is a blockchain-oriented discussion, that's all a central-based system. It is distributed for collection, but all that processing happens centrally. Another metric is a good reference point is that we measure about $6.5 billion of ad spend every year. So not an insignificant effort in what we've been doing. And what I want to talk about today is specifically how big this fraud problem is and how significant it is in the context of this $230 billion market that is global digital ads. So point number one. Ad fraud takes roughly $1 out of every $3 spent on digital ads. So imagine you're filling up your car with petrol, with gasoline, and every single pumping station just automatically removed $1 out of your purchase every time you filled up your tank. How long would you stand for that? It's kind of a problem. With such a big industry, this is happening today. It's continued to happen for some time. Bots account for roughly 56% of all overall web traffic. So you think about the problem of fraud, not only is it a problem in the context of ad spend, think about the overlay of infrastructure requirements that it's placing on all of the networks and all the nodes that exist. Digital ad fraud costs roughly $16.4 billion globally in 2017. And that's from $12 billion last year. So not only is it a big problem, it is growing disproportionately. And in 2016, 29% of programmatic is considered fraud, whereas 12% is fraud from direct ad buys. Now, one of the things that you'll find if you have any relationship to media or digital ads is that ads people talk almost in a different language and they expect you to understand what they're talking about. So what is programmatic? And I just want to give that sense. These are real-time auctions that are happening between what people call supply partners and demand partners. So it's just like a regular exchange, but the auction is actually happening the very milliseconds that you see the ad on your phone or on a website. So within 100 milliseconds of the initial call request, that ad has already gone through an auction with up to 30 different, 50 different demand-side buyers who have bid on having the opportunity to represent that. Now, the challenge with that is that through the centralized model of digital ads, there are a lot of opportunities to inject fraud because of a variety of reasons. And we're going to talk about that today. As I look at this in the context of moving forward, it's projected that roughly $50 billion is going to be spent on ad fraud if something doesn't fundamentally change. So about 2.5 years ago, I kind of went down the rabbit hole of cryptocurrencies. And I was intrigued by Bitcoin, but I was more intrigued by Ethereum as a project. And as the CEO of a company who does measurement, I kind of jokingly say, when you're a hammer, everything's a nail. When I saw the model of a smart contract being abstracted, I immediately thought, there's an opportunity to actually create an Ethereum for the advertising industry. And because of our transaction volumes, it fundamentally had to be different, both in its consensus model, in the way in which the actors participate, the way in which the smart contracts work. But the number one thing that can solve is fraud. And so we're going to unpack that today. Before we do, let me just walk you through what we see specifically at Kochava. Those were global numbers. These are Kochava-specific metrics. So the 10 highest volume networks generate 84% of all the fraudulent clicks. Now, clicks are supposed to be an indication of intent. You don't just click on an ad unless you have an intent of wanting to follow that ad and do something about it. And the notion that 10 of the highest volume networks represent 84% of the fraud means the people who know how to do it are doing it at scale. It's not necessarily something people dabble in, if you will. And so they're leveraging these kind of hidden crevices where they can take advantage of the opportunity to execute on that. Secondly, 27% of these are from the top 10 networks that are fraudulent. And then finally, we have roughly, I don't even want to say a number, but it's under 10, have roughly 50% of their overall traffic fraudulent. And then lastly, 70% of the fraud includes or drives towards legitimate installs or conversions. So let me just translate what that means. If there is someone who has an app here and you have organic users, that's fantastic. If you do any ad buying at scale, you will likely come across media sources that inject clicks or inject impressions into that stream so they get credit for your organic users. And that's fundamentally what that represents, that 70% number. So it's kind of like, not only is there media fraud, there's bot fraud, there's attribution fraud because of the way in which the framework of how people want to assign credit to their ecosystem partners. So the kind of $50 billion question here is, can blockchain solve the ad fraud problem? And fundamentally, the short answer is no, because you can't just add blockchain pixie dust on top of fraud and expect it to evaporate. But the truth is, and it's a little bit more of a verbose answer, is yes. And I'm going to unpack how we believe that can be done because of what we've been working on over the last 2 years. So this audience knows very much the attributes about blockchain. And there's no reason for me to go through the merits of things like immutability, etc. But fundamentally, these four things are the things that matter. It's the addressability of actors, the immutability of a permanent record, and a mechanism of consensus that's creative to this particular industry. We just heard about a zero-knowledge proof concept for privacy. Everyone's familiar with the notion of proof of work. People are familiar with a Byzantine fault-tolerant model of proof of stake. We do a composite of different things to be able to handle the volumes in advertising in our blockchain implementation, which is called Exchange. The notion behind Exchange is that unlike a kind of financial services exchange where you buy and sell cryptocurrencies, the reason why we call our system Exchange, and it's XCHNG, is that you can transform digital ads into an asset class and trade these particular IOs or contracts between various parties and engage with your counterparty directly. The third piece is this ratings provider concept, and then finally brand protection. So let's talk about addressability of actors. So having a blockchain implementation gives you the opportunity to put a face on what is presently in our ecosystem very anonymous and very intentionally opaque. And the reason is you can incorporate a crypto key that's associated to every single actor on the model, in the framework. And that in combination with what we're going to talk about with ratings gives a mechanism where people can't simply hide behind someone else and then behave badly. That is the number one thing that's happening in digital ads, is this notion of hiding behind someone else or rebrokering these particular contracts between buyers and sellers, but being abstracted. And this notion of addressability of actors means that if there is an actor who's on exchange on our blockchain, on this it's a public blockchain, and there is poor behavior that's being performed by one of their sub-publishers, it will discredit the reputation of the vendor who has their name on the deal. So it's kind of like KYC, but for vendors, it's KYV. So having that capacity to understand your ecosystem that you're working with and a mechanism for ratings really brings that together. Secondly, our consensus model we built specifically for the volumes that we're dealing with regard to advertising. It's a very big issue to be able to handle the kind of volumes that we're doing. And when I say we, I mean as an industry, advertising, one of the central themes of a centralized ad buying and selling platform, whether it's RTB or a general purpose waterfall, is that all of the supply meets all of the demand in these centralized systems. And all of that decisioning is happening directly in those centralized frameworks. With Exchange, there's a fully decentralized ad server tier run by disinterested third parties who are miners. And the premise here is, in the beginning, at the beginning of digital ads, the concept of the central ad server meeting the advertiser and the publisher meant that advertisers wouldn't trust publishers' data, and publishers wanted to make sure they got paid, and so they didn't trust advertisers' data. And what did they do? They slapped two separate ad servers on the edges of that centralized auction framework. And so not only does the ad have to get served through this central framework, it's getting double counted because no one trusts anyone. If you extract that entire model out and say, let's create a mining framework a la blockchain style, where a completely independent third party is simply serving serve orders on a totally global basis, and those miners are elected by the system on who responds to what ad, it creates both consensus as well as significantly distributed load of all of these ad requests all over the world. And that's really interesting because it changes the whole model, and it allows the protocols for settlement of these ad buys and sells to be abstracted from the actual addressability and delivery of those ads as it gets performed. So If anyone's interested, I'm happy to talk about the consensus model and the distributed ad server and the whole bit. That's not really the context of this meeting, but this last bit is this ratings provider, and I spoke about it a little bit. I read an article from, I think it was the CTO of Airbnb, but I may be wrong about that, so forgive me if I'm wrong. And the premise of it was, in the beginning of Airbnb, there wasn't a rating system. And how often do you want to show up at someone's house and sleep in a room there if you don't know if the person's a serial axe murderer? Like, you just don't. How often do you want to let someone sleep in your house if it's the same? And when they incorporated a ratings framework, immediately their adoption picked up. And it was a really interesting thing that in a world of a trustless, decentralized environment, you need to overlay trust, but not do it simply through a series of oracles, if you will. Having said that, people trust ComScore. People trust Nielsen. And without sounding disrespectful, why people trust these companies is beyond anyone. Because Nielsen uses a box where you actually say what you're watching on TV, and you press physical plastic buttons, and it's a sampling rate of like 20,000 or something like that. It's ridiculous. We've got devices all over the world. That's not a basis. Yet, there is value in understanding how people respond and trust these sources. ComScore has a thing called ComScore 100. ComScore 100 represents the 100 top premium publishers out there. What's the basis? No one knows. The important thing is that whatever implementation of a blockchain framework that gets introduced has to have a first-party position for an actor or various actors who could be ratings providers for any sort of dimension of data that's in the system. So for example, Kochava's had fraud products since May of 2015. We're really the leader in this space, specifically in mobile. And the information we have in our global blacklist is phenomenal. And we provide that as a service on top of our customers who use us for measurement. That data could manifest itself as a ratings provider overlaid on top of this network, so that as you're establishing your ad buy, you can say, I want to have audiences that are in, let's say, California, users who play Words with Friends, who visit a Starbucks on a somewhat frequent basis, and I want to buy those users only from publishers who are above this index on fraud. Now, all of a sudden, a peer-to-peer protocol for buying media can be qualified with a source of trust, and if that source no longer becomes useful, it's a market-driven dynamic. But the point is, the open project of exchange provides a first-party, or like a first-class position for said actor. Finally, one of the most important things to large brand advertisers is brand protection. No one wants to have their ad next to something that someone would deem inappropriate. For whatever reason. We've got a very large ride-sharing company that's a customer of ours who did not like the idea of their ads being shown on Breitbart, which is a relatively right-winged website. And the reason was multifold, but that was really important to them. Brand safety is critical, and yet, in their eyes, they didn't actually know which media sources that they were buying from were ending up having that ad show up on Breitbart because of this opacity. And the reason is because when you look at these reports, all of the ad networks, all the media sources make those things opaque. And the reason they make it opaque is they say, I want to protect my media sources so you can't go around me. The downfall of that is then fraud can come in at scale. And fundamentally, the blockchain is all about creating an equal playing field for direct interaction with your counterparty. And this is one of these examples where brand protection can really be used at scale. So the final slide I have is really about the workflow of exchange and how all these things fit together to take on an overall ecosystem play. We have a model that's centered around the insertion order. The insertion order is kind of an old school way of calling a contract where you buy media, and I think it's a throwback to the print days where you would insert an ad into the flow of a newspaper or a magazine. And the concept of an insertion order is that's the contract. Today, an insertion order is a PDF that gets signed, and that's the end of it. Then you hope to God that someone in the ad operations team actually implements the ad tech so that it does what you agreed to with regard to targeting, with regard to filtering out fraud, with regard to volume, pacing, frequency capping, making sure you don't blow your budget in the first day of a 30-day campaign. These are all the things that are in an I.O. And the beauty of what Exchange really represents is it's reducing that I.O. down to the smart contract. And the smart contract itself is that definition. The second piece that's really critical of this is that smart contract is respected by the ad-serving miners. And so when an ad impression opportunity comes up, and it gets funneled through a mediation server or a supply-side partner, that ad request within 20 milliseconds can get a response from this cloud of networked ad-serving miners to either serve the ad or respond to say, I have nothing here, folks. Just let it drop through the waterfall and do whatever you do normally to monetize this ad unit. So that's the first step of that contract. The second step is ensuring that the ad is served, and then a proof of serve model so that those miners actually write to the chain to say, yep, I served that ad, and here's the key that represents it, and this is how it works. And then finally, measurement, and that's where a company like Kochava would be a first-class actor within the system to look at both on-chain and off-chain metrics to write to the chain and clear the fact that this has been delivered. And then ratings, whoever is signed into that smart contract is the delegated ratings provider or multiple ratings providers now have the opportunity to rate all actors in that process for ongoing reputation management. And then payment. Payment's an interesting thing because while everyone here is quite comfortable with a crypto wallet or the notion of an exchange that represents you in a crypto wallet, agencies, big ad buyers are not, at least in the near foreseeable future, going to start jockeying a crypto wallet in order to buy media at scale. They're going to want to still pay in fiat. Many publishers may be on exchange, but they don't want to receive tokens necessarily. They want to receive fiat payment. And so the notion of the payment provider that's a first-class actor in this model is to provide that mechanism to effectively do currency exchange for how one wants to pay versus the tokens in which this whole system runs. And in addition to that, the payment provider has an opportunity to do some really interesting kind of exotic products like factoring. So if the terms are net 120 that the advertiser wants to pay the publisher, but the publisher wants to get paid tomorrow, the payment provider can advance those funds based on the ratings of that provider on delivery and at a fee. And so all of this coming together, you know, the fundamental reason why we didn't look at how do we solve ad fraud at scale by adding pixie dust for just ad fraud is because ad fraud is a symptom of a broken system that has been kind of added to over, you know, since 1994 when the first ad was shown on the first website. And all of this is just accrued, and there has to be a unified model, and that's why we put this together. So thanks very much for letting me share this. I would love to open it up for questions. I'm sure there's a lot of folks that are related to media given the affiliate summit.
Hi. Hi, good afternoon. Here to your right.
Thank you.
Hi.
So sorry.
So I understood so far the high-level architecture, but how close is that to actual implementation? You know, we just heard today Ethereum has 15 transactions per second. You're speaking about 2.5 million that you have every second. So how does that match?
Yeah. So the success and the premise of this project is to be able to support the volumes that both we handle and, frankly, the entire industry can handle. And so there's a number of sharding strategies that we've applied as well as consensus models. So, for example, you know, we're using effectively a pseudo proof of stake in terms of consensus, but we're also, you know, the reason why these volumes are so big is because they're centralized today in large part. And so the combination of being able to change the model by having the system be decentralized, as well as some creative ways for sharding across the different chains, it allows for that. So we have built effectively a minimal viable blockchain to date. We've thrown our own data against that. We've seen very positive results, but we're spending the entirety of this the next quarter to bring it to beta to our on-exchange partners, and these are all the ad tech partners that want to bring digital ads to the blockchain. They're going to be integrating it, and then through Q2 and Q3, we're going to give access to tools makers who want to build tools for ratings and for payment, et cetera, and then rolling out in Q4 in production.
More questions?
Any other questions? Well, terrific. Thanks very much. Certainly feel free to pull me aside if anyone has any questions. I enjoy talking about this quite a bit and would love to unpack.